In this video, we're going to be working with the factor theorem. The factor theorem says that a polynomial f of x has a factor x minus k if and only if f of k equals 0. So that means that we can factor out this binomial, and then we're going to be able to keep factoring. So what we're going to do today here on this video is that we're going to use synthetic division to use the remainder theorem together with the factor theorem to figure out if x plus 2 is a factor of f of x. So as a reminder, I'm going to use the 0 or the opposite of whatever I have there. So I have negative 2. Then I'm going to write the 1, negative 4, negative 12, negative 4, and negative 8. Right? Those are the coefficient of each one. So it's 1, negative 4, negative 12, negative 4, negative 8. Right? For this, a couple of things to remember. We got to make sure that this is in standard form. So that means that my highest exponent is going to be first. So that's the degree of that polynomial. And then it should go in descending order. Another thing to keep in mind is that if we're missing any values, any terms, we're going to add that a placeholder there. So I'm going to start by doing this right here. Bringing down the 1. So 1 times negative 2 is negative 2. Negative 6, right? Because I'm adding here, so plus. Then I'm going to multiply negative 6 times negative 2, that's 12. Negative 12 plus 12 is 0. 0 times negative 2 is 0. Negative 4 plus 0 is negative 4. Negative 4 times negative 2 is 8. Negative 8 plus 8 is 0. So that means that x plus 2 is a factor of f of x. Right? When is a factor? When? It's going to be a factor when my remainder is 0. If my remainder is any other number that is not 0, that means that is not a factor. Let's see the next one. So again, let's start with negative 3, the opposite of what I have here. I got a 1, 7, 18, 14. So I'm going to bring the 1, negative 3. 7 plus negative 3 is 4. 4 times negative 3 is negative 12. 18 plus negative 12 is 6. 6 times negative 3 is negative 18. And 14 minus 18 is negative 4. Negative 4. So that means that because this number right here, this remainder is not 0, that means that x plus 3 is not a factor of f of x. Now, keep in mind the following is that this number that I make the division, which the number that I divided by, if this is a factor, that means that x equals to negative 2 is a 0 of f of x, of that polynomial. Again, if x plus t, this is a factor, that means that x equals to negative 2 is a 0 of that polynomial. Okay, so number 3, again, we're going to make sure that it's in standard form. We're missing that linear factor, that linear term. So that means that I got to place a 0 here. Keep in mind that if you didn't place that 0, this is not going to prove that it's a factor. So it's important that we write that 0 because we're missing this term right here, this 0a, right there between the a square and the constant term. Again, x plus 3, so I'm using negative 3. So 1. And then negative 3, 1 times negative 3, negative 3, 7 plus negative 3 is 4, 4 times negative 3 is negative 12, 10 minus 12 is negative 2, and so on. I'm going to get a remainder of 0, so that means that a plus 3 is a factor of f of a, and that also means that negative 3, that x equals to negative 3 is a 0 of f of a. The next one, number 4, again, standard form. I'm not missing any term, and I'm doing my synthetic division. At the end, you should have negative 8. So that means that m of m minus 6 is not a factor of f of m. And that's it for this lesson. May the force be with you.